Hello everyone and welcome to Solnet Group's webinar on safety and security on commercial and industrial roofs of PV. My name is Joanna Viileinen and I'm heading marketing communications at Solnet Group, and I'm hosting this webinar today. We welcome questions during the webinar, so you can type them into the chat and we will reply those during the webinar if there's no time for all of them. So we will be sending a newsletter afterwards and there's more replies. And this webinar will be recorded, so you will be getting a recording of it as well. We will start with a short poll to get everyone into the subject and get into the solar safety topic mood. So let's start with that one. So which sector are you working in? Can you please select the one you are from? Is it energy system planning, installation, building real estate management, retail or logistics, manufacturing, or some other area? So let's wait a while so that you can reply. We're also waiting more people to join the webinar, so it's a good way to start. Good. And we can go to the poll, back to the poll, and the next question. How much energy does your building or next project require? So please select one if you're planning a solar energy project. So here's a question for you. Is it less than 100 megawatt hours, 100 to 500, 500 to 1000, over 1000, or if you don't have a specific project in mind yet? So that's fine as well. You can choose that one then. And let's wait for a few minutes so that everyone can reply to this one as well. Okay, and then to the last question in the poll. If you are planning to install solar plants, so when will your project be realized? Is it this year, 24, next year, 25, 26, or later? So now we are getting nicely into the topic. So let's wait for a few minutes that everyone can reply to this question as well. Okay, then we are ready to move on. So let's get into this interesting topic of solar safety. You can go to the slide 2, please. According to Clean Energy Associates, 97% of solar panel installations have major safety concerns. So this is why we are all here today to discuss this topic. And we have a great line of speakers today. If we go to the next slide, I can introduce you to George Stockschleder, who is the global practice leader of property at Zurich Insurance. And then we have Chris Foote, Director of Key Accounts Europe at SolarEdge, and also Artur Kulvik, the founder and Senior Vice President of Solnet Group. So George, could you please start by introducing yourself and telling a bit more about Zurich Insurance? Thank you.
Yeah, sure. Thank you, Joanna. Yeah, my name is Georg Stockschleder. I'm located in Cologne, Germany. and I'm the global practice leader for property in Zurich's Global Technical Center. I'm now 8 years with Zurich. I started as a head of risk engineering here in Germany, but a couple of years ago, I moved into the Global Technical Center. Before Zurich, I spent 20 years with the British RSA, and I worked 4 years for Chubb Insurance before that. The Global Technical Center and the risk engineering in general, they are part of the Zurich Resilience Solutions, ZRS, which is the risk engineering and, say, the risk engineering services arm of Zurich. We provide a network of currently about 870 engineers in 40 countries, and we are conducting about 60,000 risk assessment, depending on how you count that, per year. Besides the core risk engineering lines, like property, business interruption, technical insurances, liability, marine, and so on, with ZRS, we have further expanded our expertise and our services into climate change, resilience services, supply chain risk management, and also cybersecurity, simply to better reflect our customers' needs. And to give you a little bit of an insight about the spectrum of tasks that we are covering in property, so my area, over the past months, we spent time, for example, on fluorine-free foams. So we spent time on top-loading automatic storage and retrieval systems, electrical vehicles, and modern cars in general, and of course PV systems. Our today's topic. And of course, we don't do that in that kind of research and knowledge building in isolation. We do participate in national and international standard committees, both in the US and here in Europe. And we also talk, of course, to our customers, the fire protection industry, manufacturers, and service providers. And that is actually how we got in touch with the colleagues here from SolarEdge and Solnet. Okay, and then thank you, of course, for having me here today.
Okay, great. Thank you, George. Then we go to Chris Booth from SolarEdge. So we can go to the next slide, please.
Yeah, good afternoon, everybody. Welcome. We have a lot of attendees for this webinar. So I'm looking forward to inform you as much as possible about the potential questions you have definitely on this. So I am leading at SolarEdge the European unit of enterprises. So people call it key accounts, but we call it direct accounts, meaning that we are interested, of course, to understand and to listen to the accounts, to the enterprises, what are the needs, how they would like to decarbonize, how would like they see the high taxes and everything to avoid and to get more neutral in the CO2 world. So if you go to the next slide, you can see a few numbers at SolarEdge. So since roughly 5 years, SolarEdge is the #1 on inverters technology. So probably most of the people will know SolarEdge, that we have not only the inverters, but that we have full scope of material, which is including EV chargers, storages, energy management systems, and so on. But if you come back to the inverter itself, we have the inverter technology, which later on this webinar I will explain a little bit more, combined with our unique proposition, which are the optimizers, the so-called optimizers. Those optimizers are definitely one of the most exciting and, let's say, patents which we have. And later on with Zurich and with our colleagues, we're going to explain you more. But knowing that we have roughly 5.5 million inverters shipped in our lifetime from SolarEdge. Actually, we are listed on the stock exchange in roughly 7 years now. We have installations around the world, which is a value of 52 gigawatts, more or less. And we have all those sites, the 3.6 million sites, we are monitoring live, which means gives us a lot of data, which we can use, of course, to get even more efficient at the solar parks and the solar plants on your rooftops. If you go to the next slide, you will see that we don't have only in Europe a presence, but that we are active in more than 140 countries where we have installations. We have our own presence in more than 36 countries and a lot of facilities we are producing. We are producing in countries which are not always located in the European countries, but at the country where we are the most active, like the US, like Europe, like definitely Vietnam, Israel, and so on. So if we look again at the numbers, we have a network of 63,000 installers in this world, which means that anywhere where you think you have a need of PV, we definitely have a partner who can support you. So going to the facilities where we are producing in the next slides, you can see that we don't see it, but we have a lot of facilities around the world. It's okay. We have a lot of facilities around the world where we are producing, and we have R&D centers.
Yeah, Chris, I moved it to later, so you can go into more technology later on.
Yeah, okay.
But yeah, let's move on to Arthur. So if you can present yourself and tell a bit more about Solnet Group. Thank you.
Hi, Arthur Kulvik, one of the founders of Solnet, and I'd like to welcome everyone to the webinar on my behalf. So a little bit of background about Solnet, founded in 2014 in sunny Finland. We have from there expanded through Europe and have our offices in Helsinki, Amsterdam, and Frankfurt, servicing customers across Europe. And our main focus is really the C&I factor, our sector. I would say that a little bit extended. If you'd like to think of it, it's more we focus on site and near site, mainly behind the meter application of solar and energy storage. And if you go to the next slide, this describes a little bit of our customer segment. So our customers, I'd say, are a little bit more on the demanding side. They also know what they're procuring. And since the beginning, we've really focused on looking at kind of the EPC approach in a sense of finding the best suited solution for each of our customers and each location. So we really do a wide range of solutions, from facades, carports, and near site applications, not just the traditional rooftop. And we provide energy storage solutions and of course the O&M services for all that we install and assets of our customers. That in a nutshell about Solnet. Why we're here is that we've always focused on really the quality of engineering and safety. We've worked for a long time with SolarEdge and with Zurich to really look at what are kind of the meaningful factors to focus on, and that's today's session's main point, is to kind of look at this from a technical perspective, but also practical application for our customers' needs.
Great, thank you, Arthur. And I think my first question goes to you, because many companies are transitioning to solar. Why do you think companies are considering PVs?
So of course, there are many reasons. We're looking at kind of the recent development on how important it is to combat climate change and move into renewable production. Companies have made the commitments, but it's also a lucrative, good investment. We are doing this on a scale that it's actually meaningful when looking at the energy procurement for a fleet of assets, for example. So we're not talking about small individual projects. We're talking about looking at large pools of assets and deploying solar across them where it's suitable. So we're looking at kind of the financial incentives and those softer values like battling climate change and reducing your CO2 footprint. But all of these are coming together as kind of that attractive proposition for companies to do this on scale.
Great, thank you. What about you, Chris? Can you tell your take on this topic? Why do you think companies are moving to solar?
I mean, as Arthur is saying, there's a lot of pressure from the government, definitely. So if you don't have, let's say, an ESG strategy or to reduce your carbon emissions, you will be punished by the government by paying high taxes, or you can be punished by the banks. They don't give you a loan or a credit to lower rates. Also, this is enforced by the government, of course, to get the, let's say, the emission they have provided or that they have foreseen to get the credits for, which they reduce every year by year. They're definitely gonna forward that towards the customers and toward the enterprises. That's one thing. The second thing is, definitely is also an image point that people would like to be more neutral and show that towards their customers that they don't have a huge carbon footprint on the market. And third, but not least, and I think that's the one important topic which we're going to discuss today, is to be more independent from the energy, which can increase by the grid operator or can decrease, but it's not really stable. So we have seen all what is happening on the world, in this world, by the war, by different wars which we have, and it's all affecting definitely also the energy price. So being more independent, having self-consumption is an important topic.
Great, thank you. And if you go to next slide, so George, you have also noticed TURI insurance that companies are moving into solar. So what prompted TURI to create a white paper about photovoltaic systems on buildings? Can you tell a bit more about that? Thank you.
Yeah, I think Zurich has always, insured PV systems, in the framework of our large industrial and commercial business. Yeah. And in contrast to other renewable energy sources, photovoltaic is relatively easy to install, from small scale installations to very large systems. You just need an unshaded vacant area, and then of course roof areas are ideal for that kind of application. Now, as Chris just said, since the latest energy crisis and the quickly changing mindset regarding fossil energies and carbon footprint, that has accelerated that trend towards renewable energies, and we see a strongly increasing demand for larger PV installations, particularly in our commercial and industrial book of business. And of course, we also see losses caused by PV systems. So it was probably a mix of the actual customer requests that we received for technical guidance and our observation that PV systems may affect the core risk of our insureds that prompted us to create guidance for PV systems, which we have then summarized in this white paper. In very rough terms, the white paper covers the pre-design, the design itself, the installation, and of course also the operation, including aspects of inspection and maintenance. Yeah, that all intended to embrace photovoltaic and of course to reflect our Zurich's sustainability vision. The high-level objective in the white paper was when our PV guidance is applied, that the PV system will have no, or let's say better, a neutral impact on the overall or core risk. In other words, a good risk remains then a good risk. Yeah. On the other hand, it should of course be understood that the installation of PV does introduce an additional hazard, which, if deficient, should have an impact on the overall risk. Yeah? So in the context of our so-called risk-based assessment approach, we characterize risk by its exposure, and you see that here on the slide. And the exposure actually represents the value at risk, then the hazards, and the related controls, which may have an impact on the risk scenario severity and the likelihood. So in the context of PV, we would consider controls intended to reduce the severity on a rooftop PV fire, and we would consider controls intended to reduce the likelihood of a rooftop PV fire. And aspects affecting the severity may include, for example, the combustibility of the roof construction, the distance of PV installations to roof openings or other roof installations, then the location of the PV system on a roof, maybe over hazardous areas or operations, like an ignitable liquid operation, for example. Then early detection, that may have a severity effect, as PV fires are usually only detected from the outside by bypasses when the fire has already developed and spread. Then fire protection, that will probably have an effect on the severity. And we have seen some quite convincing fire test results, for example, from Minimax Viking. But we recognized, of course, that these kinds of deluge system come with probably significant additional costs. Then, of course, factors like roof access, the pre-fire planning and emergency planning, so being prepared for whatever type of event. And let me also add here natural hazards, which may affect the PV system. And as a note, we do, of course, share our natural hazard data with our insureds. Once we get notes, or information about upcoming projects. And we could also additionally enrich that information with future trend data from our climate change resilience services department. So aspects that may affect the likelihood would then include, the selection of certified high-quality parts and components. And I want to mention here, in particular, connectors. Then the proper installation by a qualified contractor, monitoring and approval of the installation and the commissioning by an independent third-party assurance person. Then also important controls during the operation. We talk here about the arc faults, ground faults, inverter faults, but also the monitoring of performance parameters and possible anomalies. And last but not least, of course, inspection and maintenance routines. And like I said, since PV systems are fully exposed to the elements, this will also include inspections immediately after severe weather events. And as I mentioned before, all these aspects, they should be considered through the pre-design, the design phase, the installation, and also throughout the entire lifetime of a PV system, which usually is expected to last, 20, maybe 30 years. And as a final remark, let me add that we do encourage our insureds to have a corporate PV guideline in place, simply to ensure a consistent and then also long-term approach to manage and operate PV systems in a safe way.
Okay, thank you. If we go to the next slide, so Arthur, you can probably tell a bit more about Solnet's recently published white paper in safety and security in PV. So can we move on and go to those slides, please? And then we can have the technology after that one. So if we go to this one, thank you. So if we
you can already go to the next slide. Yes,
we can go to the key findings of the report.
Looking at kind of summarizing this to three main bullets, and first one being be proactive. What this really means is we encourage customers to actually not only think about contacting us EPCs, but to look at kind of the recommendations and contact your insurer. Look at kind of the preparation of how do you define suitable assets for starting to deploy your strategy. And this is something that we encourage to kind of involve enough stakeholders early on to kind of get the best solution and best final result. If we move to the next one. focus on quality and safety. And this is really starting from engineering and like George said, choosing the right components. And looking at kind of what he mentioned, the connectors, it's not only enough that you choose the right or compatible connectors, but you need to make sure that your people and installers are trained and qualified to install those connectors. Main problem with connectors, aside from incompatible different brands and different forms being used, is actually poor installation. So crimping hasn't been done correctly, and you will cause resistance and heat in those components. So it really starts from the beginning with thorough engineering and high quality components, and then goes on to quality installation, and of course the maintenance and operation after that. So without proper ways to actually follow the system health, you will increase kind of the risk unnecessarily. So mitigating risk starts from already engineering and choice of components, but goes all the way through the value chain. If we can go to the next slide. Last one, classic data is king. So looking at once the system has been installed, the more precise your view on system health and how components are performing, the better you can actually predict and even preemptively react to issues. So looking at different systems, you will have different level of real-time monitoring available, and our focus on using optimized systems comes down to this. So getting module level statistics and a little bit more than just production values and voltages out of the monitoring helps us really plan maintenance tasks and spot issues early on. And this becomes over time a big cost saving and mitigates risks. So really being able to see what's going on is one of the most important aspects. And these are kind of the three key takeouts summarized from our white paper.
Thank you, Artur. If we go back to slide 17, so Chris, what are the benefits of optimizers and microinverters? So if you can tell a bit more about the technology behind SolarEdge's solution, and also what are the key technological consideration we need to be aware when it comes to PV systems?
Yeah, so as Artur was saying, so getting the possibility to have a control over each panel is key, meaning also definitely in the production of the energy, so that every panel can produce as its maximum. And I think it's a very important topic. So, and we call it, or it's called like the module level power electronics. If you go to the slide, the next slide, I can show you the difference between the traditional system, which you know, the string inverter system. Let's imagine, for example, you have 20, 30, 40 panels in one string. Each panel is producing or has a voltage of 31 volts. So if you imagine that all those panels in one string can push up to 1,000, 1,500 volts in a string. And this is independent if they are connected or not connected to the inverter. So those panels have in the string always the same voltage. This is topic where definitely insurance companies are looking at, that you have a high voltage on your rooftop. So there is no possibility at the end of the day to shut down it to, let's say, 0 volt, 2 volts, 3 volts, or in a low voltage system, and because the sun is always shining. So, and you cannot shut off the panel. I mean, that's the purpose of the module, that you produce the energy. So shutting it down is not the purpose. And actually, in a traditional system, you cannot shut down the panels from this producing energy. So you still have at any time the 1,000, 1,500 volts in one string. And SolarEdge said 11 years, 12 years ago, how can we change that? How can we get a system where you can control every panel? So if you go to the next slide, you can see the difference. We have in between the string and the panel, we're putting the so-called power optimizer. This optimizer, as the word is saying, is optimizing the string, meaning that every single panel is producing the energy, send it to the string we have the 1000 volt into the string as well and go to the inverter. Now, the difference what we have is that the inverter is contacting and in contact every second a few times with the power optimizer, meaning that in case of an urgency, and this can be an interruption in the string, cable is broken, one panel is not working, there is a fire, whatever, the optimizer can be shut down to 1 volt, meaning that the panel is just organized, is still producing 31 volts, let's say, but the optimizer is just allowing to get 1 volt to the string. So at the end, if you have in CNI business, we're putting 2 panels each optimizer. Let's imagine you have 40 panels and 20 optimizers behind. You have at the end only 20 volts into your string. And this is actually known in different countries as the rapid shutdown in America, where it's mandatory, where you have to shut down within 30 seconds. You have to shut down the complete system from producing energy, not from the grid, but from producing energy. And that's the big difference which we can do. This has, of course, a lot of other advantages as well. So you can imagine if one panel is not working, normally in traditional system, the weakest link is defining the chain. The rest is still producing at the same pace, at the same energy level as the weakest link. With our optimizers, you have the possibility, actually everything is remotely and automatically, where the system will cut off that one rotten apple in, as you know, the rotten apple, and will continue to produce the same energy for each panel optimized by the power optimizer. So in a nutshell, we can shut down in case of emergency, which is automatically done. The parameters are set. Can be a fire, can be a high temperature, can be the parameters we have been setting for each country. We can shut down the complete string to 20 volts, low voltage. We can optimize each panel the maximum production. And if you know, in the 20 years where Georg was telling and Arthur was saying, there is a big difference, of course, because the panels are derating and the panels are not producing the same energy anyway. So we can adapt that we have the so-called maximum power point tracking at each optimizer. If you go to the next slide, you can see at the end of the day that several insurance companies, like also Zurich, and I say Zurich is actually the first one in Europe, really pushing for that. In Americas, there is already embedded in the law to recommend systems with a so-called optimized system, which we have, module level power electronics, so that we can shut down. America is called rapid shutdown. For us in Europe, it's called Safety C, which is similar. It's same equipment. There is no additional equipment necessary, which normal inverters you have to do. The power optimizers can shut down the DC voltage as said, and of course, you can do it at any time, not only during the night, the maintenance, but you can do it also during the 20 years. And I must say, as the market has changed and we have a lot of companies now as attendees, people are not going for the feed-in tariff anymore, where you have the payoff of your power plant within a few years, and then whatever happens, people are going now for self-consumption. So they are really interested to have over the 20, 30 years, a consistent production, and of course, a safe installation, which you can provide, or which we can provide through our partners, like Solnet, of course, to have a full installation to the rooftops. And if you go to the next string, you see a little of an outlook of what we have already. So we are already in contact with a lot of enterprises on a global scale, companies like Amazon, Coca-Cola, and so on, Walmart. They are really focused on having a safe system on their rooftops. And proud, I can say that roughly 50% of all the Fortune 100 companies listed on NASDAQ and so on are using our system, A, for the safety, B, for the security on the investment, which means also consistent production. And very important, what's in the middle of the slide is the cybersecurity. So we are listed on the company, are listed on the NASDAQ. We have to get our data well stored and saved, and we protect also the data of the customers, which I think nowadays it's very important that you have some protection also on the data and the energy supply if you produce some energy on your own rooftops for self-consumption. This, of course, is a nutshell. I mean, we can have, and I really will recommend and encourage the people if they want to know more about the technology itself, because normally it will take a few hours just to explain all the advantages and so on. That please, you can contact definitely Solnet or directly to come out to SolarEdge. And if you want to write it into your specifications for tenders, most welcome to give you some tips and hints on this.
Okay, thank you, Chris. Please remember, audience, that you can also ask questions in the chat, so please do that. George,
maybe if I may add and summarize quickly on kind of the advantages of the optimizers. So in data world, the redundancy is a given thing. So that's everything that matters. But it's getting to the same point on energy production side. So looking at the advantage of optimized systems is that really redundancy in the system. So one point of failure will not take down the whole system, and the system cannot become a point of ignition in the worst case scenario. So the automations and the abilities to actually bypass individual components reduces risk, not only on the kind of practical application and fires and electrical safety side, but also business risk. So whether you're investing directly into a solar utility or getting as a PPA, you really should care whether that system produces the expected amount of energy. If it's not producing, if it's down, if it's problems that take down large portion of that utility for a prolonged time, your business case is suffering. So this is really the main advantage, is that it brings security on many aspects by bringing redundancy into traditional systems.
Right,
so
good
adding also Joanna to that, so what insurance companies are looking for, I mean, it's always good if you can early detect some point of error. It's even better to predict and to foresee that it will not happen. So, and even there we have some added connectors also that, which is, we call it Sense Connect, which can measure also the temperature into the cables, and which we can shut down that part of the system already in advance before something can happen, like a light arc or something like that. So I think insurance companies are really looking for that. So not only the detection, but also the prediction of the possible failure, which can happen always.
Yeah, good. And I was going to ask George, what are the benefits of optimizers and microinverters from an insurance point of view? So if you want to say so, continue on what Chris said.
Yeah, I mean, in brief version, and Chris and Arthur already explained that a little bit to us. For us, it's really the control of imbalances in the DC circuit, and the control of the DC voltage, particularly in emergency situation. And this is again important, to control the actual ignition source. For example, that deficient connector, and B, of course, to provide safe conditions for firefighters and others on the roof. Under normal operating conditions, the high DC voltage is not a problem. But with an arc fault, these arcs may ignite plastic parts, they may ignite combustible roof elements. So the exercise is really then to either disconnect the energy generating panel from this array or from the grid, from the DC grid, or to control the output voltage to a safe level. And this is only possible if you have that switch or that a control box directly at the panel. And as Chris just explained, optimizers can reduce then the output voltage to 1 volt, and we consider that, of course, as safe. so regarding arc generation. Another benefit of the optimizers versus simple, let's say, switches is, of course, that they monitor numerous operating parameters, yeah, and then they can detect, any kind of trends or anomalies in the DC grid, yeah, and that they can actively control these imbalances between the panels, yeah, for an optimum energy output, yeah. And I think Arthur mentioned that independent from the safety aspects that we discuss, yeah, even that probably slightly higher investment in that kind of technology would then simply be justified, over the time of the operation, yeah, because it simply produces more and more constant energy, yeah. And with, I mean, we haven't mentioned that in detail, but with micro inverters that you can also put immediately at the panel, you also actually limit the direct current to the panel level, yeah, as the inverter immediately converts the DC to the AC on panel level, yeah? So we don't have that DC grid then on the roof.
Right, thank you. And safety is so much more than just the technology. So I was going to ask after that, what do you think are the most important aspects relating to safety in solar installation? Of course, you can talk about the technology as well if you want to.
Yeah, no, I'll add a little to what George just said before that. Yeah. So looking at, we are focusing in this today's session mainly about kind of the safety aspects of a solar utility. However, what George just mentioned, the ability to de-energize the roof is not only a safety issue when something goes wrong with the solar utility, but also an emergency situation where you have a building fire that's unrelated to the PV system. Without being able to de-energize the roof, the fire department is going to have to take this into account in precautions and how do they actually approach that building's safety. So if you're able to securely de-energize the roof, yes, there is more materials on the roof, but at least it doesn't impose an additional risk to the first responders. And Joanna, if you mind repeating the question you had.
Yeah, I was just thinking, what do you think are the most important aspects relating to safety solar installation? So because safety is so much more than just the technology, it's about the professional installation also, and the quality, how you operate.
Well, it's really looking and understanding the built environment. So looking at fire sectioning, looking at adequate safety and or maintenance routes between arrays. Of course, we've been repeating the quality components and quality installation, but you also need to take into account what other actions are done on the roof over that 25 to 30 year period. So if you don't take into account what are the other maintenance tasks on the roof, you will have surprises down the line. Most of the events on the roof and maintenance tasks are usually unrelated to the PV system. So all of this has to be taken into account to have to reduce kind of the risk of systems and to make sure that the system doesn't bring new risks for other maintenance tasks. So leaving adequate safety spaces from roof edges to looking at whether there's ventilators and things like this that need to be maintained on the roof, so keeping enough distance to those, having certain areas available for actual hoisting up and down other materials than the PV system. So the kind of overall holistic thinking about this is why we are encouraging to be proactive in the beginning. So contact your insurer, look at the buildings with a constructional engineer to verify from roof conditions to load bearing capacities. There are a lot of solutions that can be mitigating these issues, but really the key point is to be kind of well informed in the beginning when you start the projects. So this will help you kind of form a more structured plan for fleet management and down the line kind of asset management for this 20 to 30 year period where the utility is going to be on the roof.
Yeah, and as you mentioned, the lifetime of the solar plant is approximately 25 to 30 years. So one needs to be considered there if you think about after the plant is installed. So what about the...
This is an interesting question in the sense that we see constantly in kind of regular 5-year intervals, we see manufacturers increasing their warranties. So the 25-year, or now almost all of them are offering 30-year even production warranties on the modules with higher and higher percentages. We see average and median kind of product warranty going from first 10 years to 12 years, now to 15 years. And I think that this is a lot to do with the manufacturers actually seeing their product in real life conditions. Until now, we've had kind of expedited tests, and to be honest, it's fairly a short time when we have been producing modules on industrial scale and modern production lines, and we're seeing that they are producing meaningful amounts of energy even at the end of so-called end of life. So it's going to be interesting to see what the balance of kind of where that end of life comes and whether it makes sense to actually let those modules just keep producing until you need to really do a major overhaul of a roof renovation or something like that. But I think that we'll be seeing systems that are operational for a lot longer than originally anticipated. And we will see new technologies and new opportunities to actually utilize more of that built space. So whether it's walls or windows or something else. So we'll have more means of producing additional energy and manage that through storage. So it's going to be interesting to see what happens in 20 to 30 years from now.
Yeah, definitely. We move to the last slide, so I just want to remind everyone to ask questions if you have any. What about the safety risks? What are the most common safety risks? Who wants to take this? George, do you want to take that one, and why? Why do you think?
Yeah, sure. I mean, Chris and Arthur, myself, we talked a little bit about that already. I think the basic risk roots in the permanent power generation on the one hand, and the relatively high DC voltages, which can lead to quite intensive and unstable electrical arcs, and that is the problem. Because in contrast to alternating current AC, the issue with the direct current is that you don't periodically change the polarity. Yeah, so you maintain a stable voltage level, yeah, which, like Chris said, in a PV system can reach 1,000 volts and more. Yeah, and if you ask me for the most critical components, they were mentioned already. I would say the connectors, yeah, because simply a large number issue. Then of course sometimes the junction boxes, the combiner boxes, the panels and their bypass diodes, and the inverters itself. Yeah, and the issues are often caused simply by quality issues with parts and components. Yeah, if you don't use established and high quality manufacturers and then partners, then of course the deficiency during the installation process. Yeah, Arthur mentioned that these thousands of connectors, they need to be manually connected. Yeah, and things can go wrong, and this is a part, particularly the connector, that is expected to survive that entire lifetime of the PV system. Yeah, and then of course improper inspection and maintenance. Yeah, and if we are talking about the observed larger PV fire losses, yeah, we often see combustible roof elements being involved. Yeah, which can of course support a horizontal fire spread, but also the fire spread into a building. And please consider, even with a controlled PV fire, you would usually see significant water damages inside the building due to the late detection, which means that fire has already developed and spread, so that the fire brigade has to apply a lot of water, onto the roof. And then, like I said, consider that any fire on a roof will most likely damage the roof membrane. So extinguishing water will always find a way into the building. So these are the main issues that we see.
Okay, great. There's a question from the audience. Let me have a look. Do you think there will be safety standards rather than guidance coming into the Europe like there is in the US? What do you think? Chris, do you know more about your US-based company? So do you know what's the status with Europe?
I mean, you see it's already there. It's not coming, it's already there. So Zurich is doing this, but also a lot of smaller insurance companies, local insurance companies are doing this already. But the driver is not only the legislation. I mean, it's about safety, it's about safety of life, health and safety. So the companies are really getting aware about that and also saying, I mean, it's an investment for 20, 30 years. So high quality is mandatory. And it's also, they rely on the energy. So it's already there. So it's not just like it will come to legislation. As I said before, in some countries around the globe, from US to Taiwan, also in Europe, Slovenia, they have already this embedded in the law. But this is not a driver. The driver for me is just like, think logical. You have a huge investment, you are depending on the energy, and you would like to have a safe investment. So it does not be the driver by the government.
Good. And then, of course, the European Union is giving the directives on the energy performance, etc., and solar strategy, making the solar installations mandatory in a couple of years.
Yeah.
Arthur, sorry.
We have a number of let's say, regulations already and then standards in the European Union concerning PV, let's say, parts and components. We have construction regulations. Unfortunately, from our point of view, that combination, that holistic view regarding the building itself, and the PV system, that is not really existing at the moment. But on the other hand, regarding safety standards, like I said, we have talked to a number of PV related manufacturers, and we definitely see a trend that these module level power electronics, these control boxes, whatever they are, whether there's a switch or an optimizer, that they become more common here in Europe as well and will be introduced. Because they do simply a great job in terms of safety, and talking about the optimizers also in terms of the efficiency of the system.
Right, thank you. Arthur, one question for you. Are there differences between self-operated PV systems versus PV systems operated by a third party on a leased roof?
Sorry, can you repeat that? Broke up on the line.
Are there differences between self-operated PV systems versus PV systems operated by a third party on a leased roof?
Well, of course. So depending on what the business model on, direct investment and self-operated versus somebody else, the main misconception I would say is that a lot of people think that when you're taking a third party and outsourcing, so either leasing the roof and having somebody operate a system there, or doing a PPA contracting, that you're outsourcing risk. However, that's not entirely true. You are outsourcing business risk of operation to somebody, but you're still taking on the risk of that utility being on top of your asset. So looking at kind of the quality aspect and safety aspect is meaningful there, as your most valuable asset is not the utility on the roof, but what's in the building and the building itself. And then when looking at kind of the key factors on both sides, whether it's self-operated or third-party operated, you're still relying on that business case to produce the energy that is expected and predicted. This is really coming down to that quality of components and importance of operations and maintenance during the life cycle.
Okay, thank you.
May I add something to that? I mean, we were talking about the guarantees and the warranties going up to 30 years and so on. But who will guarantee that that company, those 99% of the panels are produced in China, are still there? First. Secondly, will there be an increase of the watt class, which we have been seeing in the last 5 years enormously? So will those modules still exist, those panels still exist in 5 years or 10 years or 20 years to replace that? So even there, I just would like to highlight this as well, the optimizer can take over that to reduce that risk. So any panel behind the optimizer we can handle, so that you don't have to restring or replan your complete project again. So even if you have a higher watt class or another panel in the future, you can do that.
Right, thank you. So it's 26 past already. Yeah, sorry, George, go ahead if you have still something.
A brief remark also to Arthur. With a leased roof, an important remark that we would like to make from an insurance point of view is do not lose control over your roof. Yeah. So it's a very long-term partnership that you are going into with a PV system. Yeah, we talked about these up to 30 years, and from our point of view, as an insurer, we still insure that core risk, below the roof. Yeah, and therefore our insurer should have, some sort of control, what is actually happening on the roof, and we need to make it sure that these quality parts are used, that the installation has a certain quality, and that the inspection and maintenance with that third-party partner is going well, over a long period of time.
Okay, great. So let's wrap this up. Do you want to say some final words, or just talk about the future of solar, or include them both? How do you see
maybe we can address. I just saw a question come in. Is there an economical solution for upgrading combustible roofs and insulation in an existing building? And this is what we see quite often, is that depending on the roof structure, it may be quite expensive to try to upgrade the actual roof to a less combustible or less risky one. However, there are choices in components that can be done. So looking at Fire Class A modules, using optimizers, using the right type of mounting systems, these are all ways to really look at this from a different perspective. So instead of changing the roof environment, choose the right technology to reduce the risk to a right level for that roof type. Of course, this isn't always possible everywhere, but in most cases, we can find a solution that doesn't require reinforcement or changing insulation of the roof.
Yeah.
Right.
Let me add. I mean, this of course reduces the likelihood of having a fire. Yeah, and it's a better control of ignition source. But frankly, we in the insurance industry, of course, like non-combustible roofs. Yeah, if you install that, let's say, long-term operation on your roof, I mean, you have to look when you talk about an existing roof, you have to look, into the roof parameters anyway. So it is expected that the roof membrane at least will last as long as the expected lifetime of the system is, because it doesn't make sense to exchange a roof membrane you know, halfway. Yeah. So if the roof membrane may be an issue, for example, EDPM roof membrane, then it's easy to exchange that with TPO or PV, which we consider to be more safe, than these rubber type membranes. And if you open the membrane, it may be worse, to also look into you know, some kind of fast burning insulation materials like EPS. If you exchange EPS with let's say a less critical material, whether that is a mineral wool or even a PIR material, that also gives you benefits to the overall risk. So you improve the combustibility of your building in general. And we had insureds really looking into that and making having the decision made to exchange the EDPS or the EPS insulation with a less critical material.
Good. Well, thank you. I think we need to really wrap this up. So let's go to the final slide, and you can have your short ending statements, how the final words, and if you want to say something about future of solar there, so that'd be great. What do you think?
Well, maybe if I start, I'd like to thank everyone for participating and encourage everyone to get in contact when and if you have any further questions. But what we see is really solar has become a commodity. It is being installed on massive scale, and looking at this, it brings two kind of safety and problematic issues. One is the building environment and safety over there, but we're also looking at what happens to the grid when we have a lot of distributed production capacity. This is really something that also will come in the future, and we'll probably have a separate session on that, how solar can be a part of that kind of balancing market and participate in grid supporting services, instead of just being a volatile production method that causes havoc on spot market pricing. But overall, it's really about that capability of remotely manage, seeing what's going on, and having automation in place that actually mitigates the issues that traditionally are associated with solar.
Thank you, Arturo.
Adding to that, and I leave then Georg the last words as an insurance company. So for my part, also I would like to thank everybody to participate. This is definitely in a nutshell which we have trying to explain on PV. PV is just a part of it. You have the EV charging, you have the storages, you have the complete energy management system, which we all in a group together with Solnet are offering definitely also to the enterprise, to the customers. And yeah, just for me, be ready for the future, start now, and with high quality. And that's then you can secure also the future.
Thanks. And then George.
Yeah. Thank you also to all the participants. Like Arthur said, we expect that in the framework of the current politics and the future, that PV will be basically in general an integral part of buildings. We need to respond to that. We need to find ways make these PV systems safer over a very long period of time, these module level power electronics and the possibility to control each and every panel individually. I think that is the future, and that will provide the necessary safety to that kind of technology.
Great. I want to thank everyone on my behalf and you great panelists also for the good discussion and all the participants. And let's hope we can have more of these interesting webinars coming soon. So stay tuned. Thank you, everyone.
Thank you very much.
Have a nice day. Bye-bye.
Yeah.
Thank you.
Bye-bye.
you.